education, everybody. I get the great honour of introducing Izy. This is Izy. Izy is a second-year software engineering student at UTS, currently volunteers coordinator for PyCon AU. I think we get a little round of applause for that one. And so you've probably already seen her today. She's the administrator for the Girls Programming Network, as well as being a tutor/room leader and intrinsic to the National Content Creation team. She coaches at a makerspace and robotics team for upper primary age students. She drinks too many energy drinks. She gamifies meeting people by collecting LinkedIns. So hit her up in the breaks. Thank you very much, Izy.
Okay, so the title of this talk is Data Structures: A Learning Journey. I came up with this title a while ago, and then somebody told me a much better title, so that is now the subtitle. Self-inflicting first principles of data structures for learning purposes. Now, I spent too long on this animation, so you're all going to have to be really impressed by it. Who am I? Well, you were just told, but I am Izy. I'm 19. That's me. That one is not me. Oh, I went backwards. That one's not me. I am very into music. I think my analytics from last year said I listened to 60,000 minutes. That is 41 days straight. I have calculated it. That's about a ninth of the time in the year. Yeah. Again, yes, I am very mildly into energy drinks. I don't have any stats for this one, but I should come up with some for next time because they would be high. I think I'm fine, but my parents apparently think I have a problem. I spend my time teaching several different students in several different capacities. So again, I'm part of the Girls Programming Network, which you might have heard of before and was just referenced. We teach free coding courses for girls once a term. I went as a student for 9 years, and so I'm now a tutor now that I've graduated. So that's 2 years of being a tutor, but I'm also their administrator, so I do all their emailing and flights and paying and do a lot of stuff. There's a lot of things. I write content for them and I tutor for them once a term. I also do robotics. I teach robotics out of school and other things, but mostly robotics because the other people don't want to pay attention to me. That's fine. Anyway, I recently did an internship, and that leads us to a couple months ago. Here is the story. So I was in this internship. It was more than a couple months ago now, but I was doing JavaScript tests, so I wasn't really doing anything important, but there was some really intense code in the background that I wasn't really being told about, but my boss was trying to help me learn things, and so to do that, one day when we were at lunch, he was telling me about how some of the other code worked, and he told me about this data structure that we were using, and I didn't really understand what he was saying. He tried to explain it several times. He tried. It wasn't enough. Anyway, then I went to Wikipedia. That also did not help. And at the same time, I was in a class called Data Structures and Algorithms for uni, which is a similar class to what a lot of people have. And I was like, well, it's got data structures in the name. So I went to tutors, 2 of them, and neither of them had heard of this one before. So that didn't help either. So I decided that I was just going to make one from scratch in Python, because I figured that would definitely help me learn. Anyway, the data structure was called a skip list. But what is a skip list? It's quite niche, so I'm going to have to run you through it. So here's our real-life example. You can kind of think of it like IKEA. So in IKEA, you have all those sections. You've got the dining room section, the office section, the bedroom section, the kids' stuffed animal section. And they're all you're meant to go through them in a line so that you can buy all the things from all the sections. But sometimes you're just looking for one thing. You just want one thing. You want the blavage. And it's all the way at the end. If you know, at least in my IKEA, it is at the end. So you could just go all the way through and search everything in every single section, and it would take you forever. Or you could use some shortcuts that they've actually got to cut through, and then you only have to search the one section, the stuffed animal section. I love a blavage. I have a 1.7 meter blahage. It's great. I love it. Anyway, so how do they actually work? Well, we got to start from the start, which is linked lists, as skip lists are built off them. Basically, with a linked list, if you want to store a bunch of data, you can either store them next to each other in memory, but that can get a little bit confusing if you want to add things or take things away. So it gets a little bit confusing. So what we do for a linked list is when we have a piece of data that looks like this, we have two sections. One is the data, and one is this other section that kind of works like an arrow. It points to the next thing in line, and then you can string them together like that, and you've got all of your data connected, but then it's much easier to add into the middle because you can just cut those arrows like strings. The way that I think about this is sort of like those really old snake games on the Nokia. Every time it eats an apple, it adds to the string. And so you can break apart the string in the middle. I have a diagram for anyone who doesn't know what that looks like. That's pretty much how I think about linked lists. So how would we go about searching one? So this one's in order, as you can see. But if we wanted to look for the number 8, it would take us forever. Let's see how long it would take. So we have to start at the start. It's the only place you can start. And you can't really do anything interesting. You just have to go from one to the next one, to the next one, to the next one, and next one. And then you can get to the end, and we found what we're looking for. And that was 5 jumps. Counted it. So what can we do to make this better or faster, especially for something much bigger than 6 items, yeah. The short answer is skip lists. Skip lists introduce what's called fast lanes, which only contain some of the numbers in the entire linked list with arrows that point downwards. I've said references, but it's the same thing. They're basically just arrows. So here's a diagram of what a skip list would look like using our initial linked list. So we start with this, our linked list. It's the exact same. And then we have these ones, which are our fast lanes. And they are just linked lists, but they also point downwards instead of just pointing to the right. So that means that we can start at the top and then go down. And I can explain how the search will go in words, but I have an animation later, so we'll get to that when we get to that. But if we're looking at this, how would we add a number? There's some special steps we have to do, so I'll run you through it. We start with our skip list, then say we want to add number 9. First of all, it always gets added to where it needs to go, and because 9's the largest, it goes to the end. And then we flip a coin. Heads. It's very fun. That means we can go up a level. So now we add our 9 up. And then we do it again. We flip a coin. And this one doesn't succeed. This one's tails, which means we don't get to add it any higher, which means that's where it ends. But why would we be flipping a coin? That doesn't make any sense. So the reason why we're doing it is to get it closer to what our perfect skip list looks like. This is what it's supposed to look like. So basically, a perfect skip list is where you have the base list, and then every second item goes up, and every second item from that goes up. So basically, it ends up looking like a really nice curve, and it makes it so that it's sort of like a binary search when you're looking for it. You can split everything in half, in half, in half, which makes it really fast for searching. If we look at how many are in the top, we've only got 1, and then 3, and then 7. So since every succeeding layer has half as many elements, roughly, that means that every element has 1 in 2 chance of being raised up a level, hence flipping a coin. So, told you I was coming back to it. This is how we can search a skip list. Again, we start at the start, except this time we start all the way at the top. And because we know that 8 is greater than 2, we check across, and we know that it's greater than 2, so we can check the next one, and it's also greater than 7, so we can jump across. And then there's nothing in front of the 7, so we can just go down and then down. And since there's now something in front of the 7, we check across, and oh look, we found it. Now, this was only 4 jumps, which is shorter. I know it's like so different. That's because this is quite a small skip list, so it's not going to be very obvious, but there is a way that we can think about how complex or how much work that took. So I actually wrote this talk and did it in a very smaller capacity, and they were slightly more technical, so they probably understood complexity, like they've heard of big O before, and not all of you have. So instead, I'm explaining it for you. Woo! This is proof I learnt things in my uni courses. Anyway, so when we're looking at complexity, it looks at the computation required to do a task relative to the size of the data set. So that's basically how many times we have to loop or call functions or do like these really big tasks for how long your data structure is. So ours is only 6 elements, so it doesn't matter how many loops we do, that's still going to be very small. In order to show this relationship, all constants are ignored. So if it's like n on 2, which is technically the average for a lot of things, it would just be ignored, so it's just the n, because that shows more of the relationship between smaller and larger sizes of data and this like complexity. We call it big O. I actually don't know why. Probably somebody told me at some point. But big O is to test what the worst case scenario for this would be, and big theta is for averages. So if we want to look at the complexity of searching a linked list versus a skip list, we start with our big O. We've got, for a linked list, that's n, which means if we have 20 elements, our complexity is roughly 20. You have to look at every single element in the worst case. For a skip list, it's also n. But why would you do it if it's literally the same? Because that doesn't make any sense. So let's look at the averages instead. So the average for a linked list is n. Technically, it's n over 2. But because we ignore the constants, it's n. But the average for a skip list is log n. Now, some of you might not be able to do graphs in your head, so I've made you one. Basically, that's a really big difference. Not when you're really little, like 5 or 6, but when you get all the way over here, it's a very big difference. I have this written down. That's the difference between 1 million and 20. So if you had a linked list of the size of 1 million and you had to search for an item, your average would be 1 million searches, whereas with a linked list, it would be only 20, which is significantly better. So now we've got to go into the section of how I actually went about coding it. So I had 3 main steps. First one was to create a linked list. Skip lists are based off them, and they require them to run, as you can remember from the diagram, so I had to start there, especially because I needed to have a lot more control than if I just used a linked list that already existed. And then step 2 was practicing. I will get back to that, but there was practicing involved. And then step 3 was actually making the skip list. So to make the skip list, it involved 3 separate classes, which is a lot. We had one to store the individual values, so that's like our boxes from the diagram. One to store the positions in the list, which is like the little ball. Basically, it remembers where we're at, so we can loop through it much easier. And then one to connect everything together so it actually becomes a linked list. This meant creating a total of 40 methods, which is so many. This is an overview of the functionality I made for linked lists specifically. First thing I made, and this is based off the linked lists class that's in C++, which is what my data structures and algorithms class was in. But I wanted to do it in Python so that I could practice my classes in Python, and also because I can't put Python on a resume if I'm not confident in it. So I felt like I had to be confident and do it in Python. So first thing I did was pushing to the front and back of the list. So that's just adding anything to the front or back specifically. Then the next one was making indexing work, which is basically making it so that I can do list position X and either find the value that's there or store one in there. And that's using those funky looking methods called getItem and setItem. These are specific methods that are actually known in Python. They're called dunder methods because they have two underscores either side. And basically, Python looks out for them and it's like, well, I know this one, so it means that I can use standard notation like list position x equals something, just like you would do with a regular Python list. I didn't really know about these very much. I knew of them, but I'd never used them before. So I had to learn a lot about them while I was doing this. Next one was popping the first and last elements, which basically means taking it and cutting it off from the list. It doesn't exist anymore. Disappears. Next one was getting the len and the in functions to work. So that's more dunder methods. So I can find out the length and check if things are in my linked list. Then adding and deleting. Deleting is very hard, actually, in Python, because in C++ it's really easy. You just kind of say delete. In Python, that's not a thing. So I'm hoping it counts as deleting to just ignore the memory, but it is technically there still. And then being able to print the list was the next thing. This is not in order of what I did it, obviously, but printing the list, you can actually use this dunder method, the format one, to make it so that when you print the list, it can print however you want it to look like, which was really helpful, especially for the skip list. It meant that I could look at it and test it. Then I had to make this one so that the skip list would work, and that's sorting. So with a skip list, everything is sorted, and it has to start sorted if you're starting with a list initially. And to make that faster, I made a sort algorithm for my linked list. I couldn't be bothered to do anything better than bubble sort. I did think about doing quick sort at one point, and then I didn't because I did not want to. There are lots more. I don't even know why I did as many as I did, but there are tons. Some of them were required for my practice, and some of them were just because I'd heard of them. Okay, next one. So the practice section. In order to practice making difficult data structures in Python, I decided to recreate an assignment I'd done for my class, which was making a hash set, which took a lot of work in C++, slightly less work in Python, luckily. So yeah, I made a hash set from scratch because I was really confident I knew exactly how it worked, because I'd done it before. I had to make every single method before, and all of it I had to do in C++, which is C++. This took another 18 methods, which aren't even in the final skip list. So it was like 18 methods that I didn't even need to do, but still, that's even more. I am not keeping a running count of methods, but I think we're up to 58. Anyway. Finally, making the skip list took 2 more classes. Yay. One was to use the linked list object for the, I think that this doesn't make sense. Anyway, one was basically the skip list, and one was the positions in the skip list. So when you have the higher levels, those sort of work like the regular elements of the linked list, but not really, because they have the arrows pointing down. That means my linked list iterators wouldn't work anymore because they have more information to store. Yeah, so all of that, I kind of had to do that from scratch again. This was another 28 methods. So what is that? That's 70, 80 something. I have people yelling it out. I can't hear. Anyway, so the functionality for the skip list. This was something that I learnt you could do in C++, but struggled with it a lot in Python. So in C++, you can have several of the same method, but have it have different parameters or different types for its parameters so that it can work differently based off different types. So I tried to do that in Python, and I had to do some funky stuff with the type function to test what type it was in order to do separate things with separate parameters. So this was basically so I could allow initial values to be passed in, whether that was a linked list or a regular list. And at some point, I'll probably add a skip list in there. So you can start it off with some values in it already. Again, I had to allow it to print, but this time I could let it print in several different styles so that I could see it from different views, especially if one of the formatting styles wasn't working. Made it much easier. And then I had to search the skip list, but that search isn't very standard. Like with a linked list, you're just going one, then the next one, next one. It's just a basic loop. But with a skip list, it is actually recursive, which is, I'm not great at recursion, but it technically works. So, you know, that's all I can ask for. And then some other functions like getting specific lanes given the height, and then converting it from a skip list into a standard Python list, being able to reconfigure it for a different height. So the way skip lists usually work is using maths to find out the height, but I figured that the best way to do it was to allow the user to pass in a height when they were creating the skip list so that they could decide how high they want it to be based off how much space they have, pretty much. And then I had to make some other helper methods to make sure that the rest of my stuff worked. So we're going to go over things I learned. So I talked about this earlier, but I had to use the type function in order to get some polymorphism. So example of me using that was to allow the user to insert a value into a linked list as at either the index it would need to go or an iterator for where it needed to go. And I've got some code. You don't have to read it, but it is there. You can see it says type in there somewhere. Next thing, I had to get really confident with the dunder methods. Most of my methods at this point are dunder methods. These are the ones with the double underscores before and after. They're the known Python methods. Like one of the examples, I had to use format to print the skip list in different readable styles. I think actually this is my linked list one, but that is some code that has a format method in it. Another one, I got to practice using exceptions, which I didn't really cover, but basically, if somebody was using a type in a parameter that I wasn't checking for and I hadn't written the code for, I would raise an exception, which basically throws an error. So it tells the user that they're not allowed to do that. Here's an example. And finally, I got really good at classes, algorithms, recursion, and debugging because I had to do all this on my own. I had no help. The only help I had was YouTube, and that wasn't great. So I got really good at a lot of things really quickly. Okay, conclusion. This was a massive pain. I definitely do understand skip lists now. Like, I really understand them, like, really, really understand them, because I had to make them. And it was really hard, but I learned a ton, and I think that means that you guys should do it too. I'm not 100% sure I would do it in Python next time. It comes with pros and cons. Cons are that you don't have direct data management, so a lot of it you have to fake, and it kind of gets a bit messy. And the pros are that you get to do stuff like dunder methods, and also you get to practice doing some of this harder stuff in a different language that doesn't really support it, but you can do it anyway. So doing something that the language isn't really meant to do means that you're practicing doing stuff that's a bit hard, but also doing this in any language is really helpful for learning. Like, I really understand hash sets and exactly how they work, exactly how they're set up, what the UML diagram would look like. Another thing I learnt in uni. But yeah, it was really good. Anyway, thanks.
I thought you were going. I can. I'm just going to go and give you a high five. Look at me, stalling. We do have a minute or two for questions. We can, yeah, here we go.
Did you create any test cases to see if your functions did what they're supposed to do, and maybe compare between like your C++ and your Python implementations?
So every time I made a method, I tested it. I didn't test it very deeply, as I found out recently when I was trying to test it with some larger skip lists. So there are definitely issues, and the testing was very minimal, but the methods mostly work how they should, except for when you get past 10 elements, because mostly the issue is printing. I didn't account for second digits when I was printing, so it kind of looks really ugly. But yeah, no, majority of the methods work. I didn't really think about doing this in C++, so I haven't looked at testing it alongside C++, but the functionality does exactly what it would do in C++. A lot of the functionality, because skip lists aren't really a thing that you can just use, they're not a data structure that is natively implemented in Python. You'd have to use a module, same in C++. I didn't really have anything to compare against, except I just used the standard things that you would have, like add, delete, front, back, push, pop, all of those things. Basically, I made the linked list with everything that would be in a C++ linked list, and then I made a skip list, and I made as many functions as I could think of. But that was like the extent of my testing. Some of the functions don't work, one specifically, but that's fine.
Great talk. What data structure are you going to build next?
I was thinking a red-black binary tree.
Oh, I don't know how to build that.
Yeah. That's another... when I did this in a smaller version, somebody asked me why I didn't use that in my internship, and I didn't have an answer for them because I'd never heard of it before. And I had to... I think they were mostly asking it because they wanted everyone to know that they knew what a red-black binary tree was. So, yeah, but that will be next, maybe, if I ever look at this code again.
You mentioned the special format method. What does that actually do?
So with the format method, if you've looked at format strings or f strings in printing before, basically it means that you can customize how those f strings behave with your object. So when you're printing, usually you can print any type of object, and once it gets to objects it doesn't really recognize, it just prints a thing that says the object type and then a random code of numbers and letters. But if you use f strings and you use the format method, you can customize how that gets printed. So if I go back to the section of code that I have for that, is that it? Yeah. Basically what this one's doing is it's looping through the list, like it starts by printing out the open list, then it loops through every item in the list, and it prints out the item plus a comma and a space, and then prints out a closed list. So that's basically how it would happen for a regular list. This was just so my linked list would look the same when you printed it out. This means when you use an f string or a format string on the object, it will print out like a regular list. And so I have several of these for my skip list. If you look up the top, there's a parameter called format specs that's required for this function. And that's basically, you can pass in whatever code you want to write. Like it's usually a code like LL or whatever string. You pass it in, and then you can test for those, so you can format it differently based off what you've passed in. So I did a linked list version, I did a skip list version, and I did one other version for my skip list so that they printed in different styles.
Okay, I think we've run out of time for questions. Can we please thank Izy again?